Hello everyone, I welcome you all to this class. In our previous class, we started this topic, derivative of inverse hyperbolic functions, and we actually started a class with a particular example. So we want to look at more examples under this very topic. So in this question, they said if y is equals to hyperbolic cosine inverse of x over a, prove that derivative of y with respect to x is equals to 1 over square root of x squared minus a squared. So and the second one is if y is equals to hyperbolic cos inverse of sec x, find the derivative of y with respect to x. So let's consider the solution of this question. Now, the first one we are required to, what they ask us to do there is to prove it. So let's look at the proof. We are given that y is equals to hyperbolic cosine inverse of x over a. So this implies if you have that cosine theta is equals to 1 over 2, then if you want to get your theta, you now say theta is equals to cosine inverse of 1 over 2, right? We know this, right, from trigonometry. If cosine theta is 1 over 2, then if you want to get theta, you take the cos inverse of 1 over 2. So if you compare it here, so if you have theta is equals to cos inverse of 1 over 2, then it means that cos theta will be this 1 over 2. So y is equals to hyperbolic cosine of x over a. So hyperbolic cosine of y, if you compare it here, cos theta will be this quantity. Hyperbolic cosine of y will be this quantity. So this implies that hyperbolic cosine of y will be this quantity here, x over a. So now what do? We make x the subject of the formula. So how do you make x the subject of the formula? You can cross multiply, or you multiply both sides by this denominator a. So let's multiply both sides by this denominator a. Multiply here by a and a will get cancelled, right? So if you put a times here and multiply this side by a, multiply this side by a, you multiply here by a, this a and a will get cancelled. So what will now remain is your x equal to, multiply here by a, you have a hyperbolic cosine of y, right? So x is now made the subject of the formula. So x is the dependent variable while y is the independent variable. So you now differentiate this dependent variable with respect to independent, right? So you differentiate x with respect to y. So derivative of x with respect to y will be equal to, if you differentiate hyperbolic cosine, you get positive hyperbolic sine. We saw that in our previous video, right? Then we are looking for, in the proof, we are looking for the y, the x, not the x, the y. So to reverse it, you just take reciprocal if you want to reverse it. So we'll now say taking the reciprocal of both sides, we get, so if you take reciprocal of both sides, reciprocal is just 1 over, right? So we get, so take reciprocal of this, that's 1 over the x dy. Whenever you take reciprocal of a fraction, that's 1 over a fraction. The fraction reverses. The denominator will come up, while the numerator will come down. So the fraction reverses. So the y will come up, the x will come down. If you take, anytime you take reciprocal of a fraction or 1 over a fraction, denominator will come up, numerator will come down. So with the y will come up, while the x will come down. We now get this equal to, so do the same thing as you are doing it at this left hand side, you are also doing 1 over this one. So you do 1 over is hyperbolic That's 1 over this one. Hyperbolic sine of y. So we have done here, we have done here, both sides, right? So then we have gotten that dy dx is this 1 over a hyperbolic sine of y. So, but in our proof, dy dx is written in terms of a, x and a. So what do? You go to the first step of your proof. So after writing what is given to you, the first step you took is this one. So here we're having hyperbolic cosine of y is x over a. So for us to bring in x over a here, we're having the hyperbolic cosine of y is x over a. So for us to write this hyperbolic sign in terms of x and a, we have to write this hyperbolic sign in terms of cosine, so that we can now replace cosine with x over a, right? So we use the identity, the relationship between hyperbolic cosine squared and hyperbolic sine squared. We saw that in our previous video. Hyperbolic cosine squared x minus hyperbolic sine squared x is equals to what? 1, right? But and we want to write hyperbolic sine in terms of what? Hyperbolic cosine, so that we can replace hyperbolic cosine with x over a, right? So let's make hyperbolic sine the subject of the formula. So if you move it to the other side, this minus will become positive. You have positive hyperbolic sine squared x is equals to, so as I'm moving this quantity to the right, I've moved this one. As I move this one the other side, I'm moving this one, positive 1, to this here. If you move positive 1 here, it's changed to what? Negative. So we now have hyperbolic cosine squared x minus 1, right? So with this we have made this one the subject of the formula. So what do? We need hyperbolic sine, not hyperbolic sine squared. So we take square root, so that square root will cancel the square. So you now have hyperbolic sine of x equals, as you are taking square root here, you are taking square root here. You take square root of both sides. Hyperbolic cosine squared x minus 1. So it means in this place I can replace this hyperbolic sine y with square root of hyperbolic cosine squared y minus 1. So here will be 1 over a into square root of hyperbolic cosine squared y, hyperbolic cosine squared y minus 1. So that's what we now have there. So what's the next thing? The next thing is to simplify further. So we have written our hyperbolic sign in terms of cosine. So we have 1 over a into square root of. So what is a hyperbolic cosine y? Hyperbolic cosine y is x over a. But here we're having hyperbolic cosine squared y. So it will be x over a all squared. So if you do x over a all squared, you pass the square on x, pass the square on a, you now have x squared over a squared. So we have minus 1, right? Minus 1. So this will be equal to what? 1 over a into square root of, so 1 is written as 1 over 1, isn't it? So 1 is written as 1 over 1. So what's the LCM? LCM of a squared and 1 is a squared. A squared. So a squared divide a squared, 1. Multiply x squared, we have x squared. Minus 1 divide a squared, we have a squared. Multiply 1, we have a squared. We have a squared. So we have, this will be 1 over a into, so this is square root of a fraction, right? How do you find square root of fraction? You can take the square root of the numerator over square root of the denominator, right? If you take the square root of what this thing of the numerator, I have square root of x squared minus a squared. I have taken the square root of the numerator. You now take the square root of the denominator, that's square root of a squared. That's what is the denominator. What will happen? Square will cancel the square root. You now have your a. at denominator. So this a here can cancel this a here, right? You now have 1 over square root of x squared minus a squared. So that's what you now have. So this completes the proof. So the next thing is to solve the second question. So the second question, for the second question, question II, we are given that given y is equals to hyperbolic cosine inverse of sec x. So this is what is given to us, and we want to find the derivative of y with respect to x. So we are going to use what? Chain rule. We are going to use what? Chain rule. So for chain rule, you differentiate this quantity inside, then differentiate the quantity outside and multiply both, right? So what is the quantity inside? I will call it something. So I will say let u be equals to this quantity inside sec x. So I've called this quantity u. So if I replace this sec x with u, so what will be my y? My y will be equals to hyperbolic cosine inverse of u, because I'll replace this quantity with u, right? So now this inside is I will differentiate it, and also so my inside is, what is inside is sec x. So I've called it u. I'll differentiate it. So u is now the dependent variable while x is the independent variable. So I'll differentiate this. So now my outside is a hyperbolic cosine inverse. So but my y now is hyperbolic cosine inverse of what? U. So that's my outside. So now so y is now the dependent variable, u is the independent. So I will be differentiating this with respect to what? U, right? So now let me differentiate the inside first. The u, the x will be equals to, if you differentiate sec from trigonometry, if you differentiate sec theta, you get a sec tan theta. So if you differentiate sec x, you get sec x tan x. So this is what you are going to get, sec x tan x. Remember, this is sec. This sec x does not have h, so it's not hyperbolic sec. It's normal trigonometric sec. So that's what you are going to have. Then you differentiate the outside, the y, the u. So I'm differentiating y with respect to u. So this will be equals to, but we have gotten this from the proof. We have that if y is equals to hyperbolic cosine of x over a, then the y dx is 1 over square root of s squared minus a squared. So this u here now is this x here is u in this case, right? So this x here is u in this case. Then, but what is a? So this u here can be written as u over 1, right? So if you compare this is written as u over 1, for instance. So that x is u and a is 1. Do you get it? So that in this place, you replace x with u, replace a with 1. So you have 1 over square root of u squared minus 1 squared is 1. So that's it. So that's the result of the derivative of the outside. So now what do you do next? You use your chain rule formula. What's your chain rule formula? Chain rule formula says that the derivative of y with respect to x is equal to derivative of y with respect to u multiplied by the derivative of u with respect to x. So this is just what I explained. Derivative of y with respect to u is just the derivative of this outside, cosine inverse. So, and we have gotten it. And the derivative of u with respect to x is the derivative of the inside, which is sec. And I told you, when you do that, you multiply both of them. That's this formula. So, and derivative of y with respect to u is 1 over square root of u squared minus 1. So multiplying the derivative of u with respect to x, which gave us sec x tan sec x tan x. So that's what it gave us, sec x tan x. So if you simplify, sec x tan x will multiply 1, they will come to the numerator. If this quantity multiply 1, we now have sec x tan x. You now have sec x tan x divided by square root of, what is your u? U is a sec x, so you will have, but you have u squared, so you have sec, a sec squared x. So since u is sec x and we're having u squared, so you have sec squared, so you have sec squared x minus 1. So that's what we are going to have. So the next thing is to know if you can simplify this further. But we know from trigonometry, that 1 plus tan squared theta is equals to sec squared theta, right? So we are having, if you want to simplify this, we can make tan theta the subject of the formula, so that we will get this, what is inside the square. What is inside the square root is sec squared minus 1. So if I want to get that sec squared minus 1, what do I do here? For me to get it, I'll just move this positive 1 to the right. So I will now have that tan squared theta will be equals to sec squared, will be equals to sec squared theta minus 1. So if I move this positive 1 to the right, change to negative 1. So if I compare this, what I wrote here, with what I have here, so this expression will be equals to sec x, tan x divided by square root of, so this sec squared x minus 1, so we have it from this expression, is same thing as tan. So it will be the same thing as tan squared x. So this will be tan squared x. So this is what we have. And what will be the next thing? We have square here, we have square root. What will happen? Square will cancel the square root. So if square cancels the square root, so what you now have is, we'll have, what is at the numerator is 1 sec x, what's at the numerator is sec x tan x divided by denominator. Now square will cancel the square root, you now have your tan x left at the denominator, tan x, but we have tan x at the numerator here, which will now cancel this tan x at the denominator here, leaving your sec x. So the derivative of this hyperbolic cosine inverse of sec x is the same thing as sec x, as we got in our result. So thank you so much for being part of this class. See you in our upcoming class.